everyone. Um, so continuing from yesterday, I will be picking up another lead code problem to solve. So let's look at the problem statement. First bad version. You're a product manager and currently leading a team to develop a new product. Unfortunately, the latest version of your product fails the quality check. Since each version is developed based on the previous version, all the versions after a bad version are also bad. Suppose you have n versions, 1, 2, 3 till n, and you want to find out the first bad one, which causes all the following ones to be bad. Cascading bad versions. You are given an API is bad version, which returns whether version is bad. Implement a function to find the first bad version. You should minimize the number of calls to the API. Okay. So you have a number of versions, n versions, and you want to find the first bad one, right? And you have an API which tells you whether it is bad or not. So that means we have to reduce the number of iterations over this array, right? Okay. Let's think about it a little bit. I mean, I already know we have to apply binary search in some way because that's what it falls under in the study plan. But yeah. So you have 10 versions. Suppose you have 1,000 versions. Now, how are you supposed to know? Okay, just if you want to, so it would be 1, 2, 3, 4, whatever, right? No. So suppose the first one that you check is the middle middle index one, right? Which is say, suppose you have 5 versions. So middle index version would be, you find the middle would be 3. First you check for 3. So now it returns false. What does that mean? 0, 1, 2, 3, 4. So these are your indexes. These are your versions. And so this is true, this is true, this is true. So something is false, then everything after that will be false. So suppose you are at index 2, version 3, and it returns true. Say it returns true. So what does that mean? So everything to the left of the middle index value would be obviously true because it can't be false, because once there is a false, everything after that will always be false, right? So you got a true, that means everything, you can discard everything on the left of that item, right? That result or whatever. And this is true, so that means the false would be anywhere after it in the second half, like in the right half of this array of versions, right? Version ka, whether it is uh, whether it is a good version or a bad version. Now suppose it returns mid index ka value, which is 3, returns false. When would it, so suppose this is false, suppose this is also false. Okay. So you came here, now you see this is false. Now you know that on the right side of it, obviously everything will be false, but you need to find the first false. So the first false will be somewhere on the left side, and it would also include the false that you got, right? So suppose if this is true, now including the middle element, you have to check where the first false is, right? So the mid one can also be included. Now, when you take that and you get the mid and you get true, yeah, that doesn't matter. That would be just like an extra step. Okay, so let's start coding it. Let's have our first equal to 0, last equal to length of n. Let's write our loop while first is less than. Okay, so let's see where it should end, right? So suppose you're here and your middle element is false. Now you go to the left half, including the middle element, and the middle is 1, and which is true. So you go to the left, to the right half, and there you have only one element, and there you have only one element, and yeah, it will converge to a single element, and that's the one. It should always converge, I believe. So while first is less than last, mm, we'll check the equal to first equal to last one a bit later. So let's assume while first is less than last, mm, what do we do first? We pick out the mid. Mid is equal to first plus last. And we integer it, negative because you have floor panel. If n mid equal to true, then what happens? Then it is to the right and without including the mid, right? So your first changes. First becomes n. First becomes mid plus 1. Last stays the same. Else if what is the other condition? N mid equal to false. If it is false, then the last changes to becomes mid, right? Because it also includes mid. Do we need another condition? Else. So we do it blah blah blah, and then when it becomes equal, we just return that one because it will always. Um, what do we need to return? Which returns when the version is bad. And you want to find the first bad one. You're given an API which returns when the version is bad, and we have to find the first bad version. So n equal to 5, bad equal to 4. So output is 354. Acha, the version, right? So it's n mid. So you return n mid. It can either be equal to true or equal to false. ELSE. Mm, oh, it's not an array. So, uh, it's not length. It's the version. What is n? N is all the versions. So n minus 1. Oh, then this will not work. Wait. If n mid, I was assuming this is an array of versions. Great. Um, so it is just a number. Mid is equal to, I guess, mid itself. So like mid plus 1, probably. If mid, last is n minus 1, mid is first plus last. I guess you just make it as 1 to n, and so we don't need indexing in that case, right? We can just have the first as 1, last is n, while first less than last. Mid is equal to this. If mid plus, we don't need a plus 1. We just keep that as the version. So if mid, I guess we'll make a call to the API, is bad version. Completely forgot. There's an API which returns true. If is bad version mid equals to true, so we are passing the version here, and if this is true, then first mid plus 1, else last equal to mid, return mid. Wrong answer. Well, obviously. Anyway, let's see where we went wrong. Your input is 5. So first equal to 1, last equal to 5, while 1 is less than 5. So expected is 4, right? So true. This is true. Okay, so mid is equal to 1 plus 5, 6 by 2 is 3. So mid is 3, is bad version 3 equal to true? It is true, which means first goes to the next. Mid plus 1. Mid is becomes first becomes 4, and last stays the same. So now you go back. First is 4, last is 5. Mid is equal to 4 plus 5, 9 by 2, which is 5. I don't know, is it 5 or is it 4? How does it round up? Well, let's consider it to be 5. Um, if is bad version equal to true, else last equal to mid. It is not true, so last becomes equal to mid, which is 4. So it comes last becomes equal to mid. If it is false, wait a second. So we were at 4 and 5, and 4 is first, 5 is last. Here, last becomes. But shouldn't it be both? How will it become 1? Um, I think there is some. I got a little mixed up. Okay, let's say first equal to 1, last equal to n, which is 5. Let's print mid. And let's see where it is going. Let's just see. Print. Um, what are we going to print first? And okay. Why is last equal to 3? Oh no, there's something wrong. Last equal to n, which is what? Shouldn't n be 5? Why did n become 3? Um, last is becoming. Oh, okay, okay. I have printed it. Okay, initial it was 5, now it became 3. Mid is 3. I think this is not correct, but okay. First and last were 1 and 5, and so mid became 3 if bad version equal to 2. 3 is true. It should go here, right? So first, is bad version mid not equal to true? In the first case, it should be false. Oh, okay, okay. Ah, I think I got it opposite. So false is if we false is that this version is good, and yeah. Okay. That took a while. Before assignment. Mm, 1. When it is 1. Suppose you have 1 and you have 1. So it doesn't go inside, and oh, okay. It doesn't go inside at all. Just make it as first. Sugar 2. First is 1, last is 2, and that is equal to 3 by 2 is 1. That is equal to 1 if bad version 1 is false. That means it is not bad. So it's not bad. To completely key structure. To completely let go of this now. It's a good version. This means good version. Good version means if bad version is false, that means it's good. That means you go to the right side. Mid is equal to first is equal to 2. Last is equal to 2. So it should return 2. Why is it not? Let's check. Probably return first. Instead of mid, maybe. This took a while. Do I want to do another problem? Search insert position. Let's continue later sometime. That's all for now. Thanks. Bye.